All right, who here has access to the internet? All right, I want you to go to YouTube. Everyone at YouTube, search Aero, A-E-R-O, space, educator, space, network. EDUC numeral 8, letter R. Okay. Everyone see that? Now, subscribe. Look, 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 seek, and ye shall find. Now, this, Lord willing, is going to be our new broadcast standard platform. The difference is going to be that right now this is public while I test it. I will be changing the classroom components to, you just turn the volume off, okay, because it's just going to create a volume loop. And try not to act like everybody does when there's a camera around, you know, where you just lose your minds. So let's just, okay. So now this is going to go ultimately private on the classroom components. However, some of the other components that we do with regard to interviews, with regards to some of the special video stuff that we're going to do, that will be public. This portion of it is proprietary. And so for this, it's got to be private. And again, because of the fact that it shows children in a video, we have to make this private. All right, so that will be changing. In order for that to happen, I will send you to an email address the actual permission to view the private content on our YouTube channel. Now, to do that, I will need an email address from you. All right? It must be an email address that will allow you to receive and watch that content. Here is the email address I want you to use to communicate with me, that email address you would like for me to use. What did I just say? You are going to send me an email to that address with the email you want me to use. I'm sorry? Whatever you want to do, but we're going to get on with the proceedings here. All right, now. Oops, don't want that.
So I should just email you my what should I email you?
Hi, Mr. R. This is Elijah. Please use this email for my communications. There you go.
And the G and the Q are lowercase?
Wait, there's a Q?
Wait, no, yeah.
Yes, it doesn't matter when it comes to email capitalization. You should know.
Everybody got that? Now, let us continue along our drawings here with regard to what? What is it that we're studying? Okay, the 4 strokes of a 4-stroke engine. Nicholas Otto, German engineer, is the one who came up with this neat little idea. So it's also in some circles referred to as the Otto cycle, O-T-T-O cycle. Yes.
I have a question.
I have an answer. Let's see if they match.
What is a two-stroke engine?
What do you think a 2-stroke engine might be?
It only has 2 strokes, but
Thank you.
what are the 2 strokes? Does it let in the fuel-air mixture and burn it in the same?
So what it won't let it in and burn it. But what happens is it combines. Let's get the 4 here first, and then let's let you decide which 2 they might actually combine.
Does it combine air and fuel as it goes down, or as it strokes down and as it strokes up?
What did I just say? What did I just say?
We said let's wait until we understand the 4-stroke engine and decide what we think they would combine in the 2-stroke engine.
Thank you. There you go. Number 1 stroke is what we call the intake. All right. So, as we look here, let's take a peek. All right. So, what is happening here? In this stroke, number 1, and I want you to look over here. Number 1, what's happening here, Elijah? What is this, first of all?
That's the piston.
Okay, what are these little dots? What do those represent?
Like lines of the metal.
The piston rings, thank you. Okay, it's moving toward what? The piston is moving toward what? Okay, toward the crankshaft. So it's moving toward the crankcase. As it moves toward the crankcase, it creates a vacuum in this.
It's I know what it's called.
I know what it's called too, but I'm forgetting.
It is a space. It's a
Combustion chamber. Creates a void in the combustion chamber. As it creates a vacuum here, this valve called the intake valve opens and allows what to come into the combustion chamber? Fuel-air mixture. FA stands for fuel-air mixture into the combustion chamber. What is this valve called? The exhaust valve. Is it open or closed? Okay, what are these 2 things at the top and the bottom of the cylinder? Spark plugs. Are they sparking yet? Nope. What is this thing over here? Fuel injector. That's a little bonus thing. In the absence of a carburetor, meaning that you have a fuel injector, you're going to have a fuel injector somewhere here on the top portion, or this near the valves of the cylinder, that will squirt in a metered amount of fuel whilst this intake valve is open, bringing in just air. But in a carbureted system, it's going to suck in air and fuel. Okay? So that's what happens here. Right? Good so far. So now then, explain to me then what's going to happen on this on the second stroke. Compression. So, with compression, what's happening? Which way is the piston moving?
It's going up.
Okay. And what's happening here with these valves now? They're both closed. Okay. Here's the spark plugs. So what's happening now? Why is it that we're squeezing this air and fuel together? Why do we do that, Solomon?
Compression and result in explosion to power the power plant.
Do we don't call it an explosion. An explosion is something different. This is a controlled firing that happens. However, The second phase here, this second stroke, is we're squeezing this together. Why? To create pressure. Why?
Then it's easier to light.
It pushes it more. Why? Let me ask you a question. You guys have all seen a firecracker, right? All right. With a firecracker, it's wrapped with what? What is it? It's paper. So if you take that paper and you unwrap everything, what's inside?
Gunpowder.
Little gunpowder. If you take that gunpowder and you just put it right there on the table and I take a match and I light it, is it going to go bang?
No, 'cause
It's just, right?
Like in
Okay. Why?
because there's no
Because all the pressure has been released.
Oh, so you want to compress it so you get the right amount of combustion to turn the engine.
Boom. Okay? It's just kind of like why you wrap a firecracker, because otherwise you're going to put some gunpowder out there, it's going to go, and it's just, that's no fun. And so when you wrap it really, really tight and you get all those molecules together, what happens is they all interact almost instantaneously as opposed to one at a time. The one at a time is where you get the, but when they almost all kind of work together, that's when you get the bang. Okay? So with this, it allows by squeezing the air and the fuel together, it makes for a more efficient, controlled firing. Good so far. So, piston is going away from the crankcase, squeezing the air-fuel mixture. Valves are closed. Spark plug is not sparking. Okay? What stroke is that? Compression, and it's number 2. Now then,
What are the dotted lines called again?
piston rings. Okay, so now we're on the what stroke? The power stroke, or combustion. It's combustion is happening in this. So here you have what's happening now. What direction? Well, first of all, what's happening in the combustion chamber?
A firing happens.
Controlled firing. And here's what happens. It moves from the spark plugs in this direction. As it does, can the gases escape this way? No. Can they escape through the valves? No. So there's only one choice for that expansion to occur, correct? Which direction is it? Toward the crankshaft, toward the crankcase. That is what turns the crankshaft. That is what turns your little spinny thingy out there at the front of your airplane. Okay? Elijah?
So when the engine is running, do they have every single piston go down at the same time, or are they differential so that they spin the other one?
We're going to talk about that when we get all 4 of them. Okay? So, we have a controlled firing. Why do we have 2 spark plugs in this cylinder instead of 1? Can't just one do the trick? So that it burns evenly, the bone doctor suggests, which is good. By burning evenly, it burns more completely, and it creates a little more power than there would be if there were just one spark plug. The spark comes from something. It comes from electricity, a signal coming to those spark plugs. They're both on separate magneto systems. Separate magnetos send the timing of the spark to those 2 spark plugs at the same time. If you lose one magneto system, you're still going to get a firing in there, but it's not going to produce as much energy. It's not going to be as efficient, but it will keep your airplane running. So why do we have 2 magneto systems sending the pulse to those two spark plugs. Elijah. Correct. Well, you're not going to crash anyway. You're going to land. It just may not be at an airport. So that's going to be the thing, is that you're going to lose a little power, you're going to lose a little efficiency, but you're not going to lose the engine. Safety and performance. Those are the two reasons why you have dual magneto systems, and it's why you have two spark plugs there. Because of safety and performance. Now, on to our fourth stroke. What's happening with the intake valve now on our fourth stroke? Fourth stroke is called what? Exhaust. What's happening with our intake valve? It's going to be closed. What's happening with our
Exhaust valve. It's open. That's what's
Open
happening.
and extended into the piston or combustion chamber.
It doesn't extend.
Well, whatever the word is.
Okay, so that valve opens, and what's the direction of our piston? Up, away from the crankcase to the top of the cylinder. Because again, remember, these are laid out horizontally. So top and bottom is subjective. So it is moving away from the crankcase, moving up into the combustion chamber, pushing out what? Exhaust. What is exhaust? What is that? What is it? What kind of gases? Not CO2. We breathe out CO2. What does an engine breathe out? That's CO2. Carbon monoxide, CO. It breathes out carbon monoxide, which is a byproduct of combustion anytime that you have this fire within an oxygenated system of some sort. So it's going to create that. It's going to create little pieces of carbon, perhaps, water vapor, but also one other important thing that it's pushing out. What happens in number 3? What happens in number 3?
In number 3.
What did we just do? Number 3 is the power. So what happens in the combustion chamber? Oh, there's combustion. So does it create what?
Smoke.
It creates smoke if you're not managing your fuel correctly. How about heat? Okay, heat. So it pushes heat out. So you have the remnants then of combustion, water vapor, carbon monoxide, maybe little pieces of carbon if you're not managing your fuel correctly, but if you're managing the amount of fuel that goes in there in your air-fuel mixture, it's a very clean process, cleaner than cars. But heat also escapes. Anders. There's two things that we can use those escaping gas for. One of them that we already talked about. Heat. How do you heat that airplane? How do you heat the inside of that airplane? You turn on, Joseph?
Isn't that kind of like how it works though?
Anders? How do we heat this? airplane. We pull a lever and we get warm air. Where does the warm air come from? The exhaust gases go through a tube, right? The exhaust pipe. Surrounding the exhaust pipe is what? You've done the reading, correct? A case, something we called a manifold. That manifold is a hollow metal case. What does it collect? Heat. We can then, with a fan, pull that heat out of that manifold into the engine compartment. We wouldn't want to just vent exhaust gases into the cabin, would we? We wouldn't want to. So we collect that heat coming off that manifold, inside the manifold, where we can pull that air through it, and we can vent that air, which should be, in normal circumstances, just warm air, and to be able to pull that into the cabin. What if there's a little pinhole in that manifold and it happens to collect some of those exhaust gases? What can happen? Why would you asphyxiate? Well, you're still going to have air, but you're going to be pumping something else in there. Carbon monoxide, which is poisonous to us. And that's one of the big things. We have carbon monoxide detectors in these airplanes that tell us if it's picking up in parts per million carbon monoxide. So that would be bad. What's the other use of that heat escaping that engine? Turbocharger. What's a turbocharger? Solomon.
A turbocharger is a device that is designed to suck in extra air.
Into what?
Into the engine.
Okay, into the cylinders, so that you have extra air. When you're able to go out there and pull in more air, what else are you pulling in?
Molecules.
What kind of molecules specifically? Oxygen molecules. With more oxygen, I can put more what into that cylinder? Fuel. I can put more fuel into the mixture. If I can put more fuel into the mixture, I'm going to get better performance, right? That's what a turbocharger does. On this airplane, there's 2 turbochargers on each side of the engine. Each side of that engine has 3 cylinders. That's a 6-cylinder engine. It has 3 cylinders. On those 3 sides, there are 2 turbochargers there that take that exhaust gas, turn a turbine that then pulls to pull more air into that engine. It will create sea level performance up to 17,000 feet. So that's the engine. It doesn't make the propeller more efficient. It doesn't make the wing more efficient, but it does provide more power, and it will ultimately lead to a higher service ceiling. And again, in this particular airplane, that's 27,000 feet. Okay? All right? Want to share that with us, Joseph? Okay. So, does everyone understand the 4 strokes of a 4-stroke engine?
Yes, sir.
Joseph? Why are you struggling with it?
Well, because I'm not totally understanding the crankshaft.
Okay. What's your question?
Well, in the spark plugs, and how we're generating the power from that from the battery, and
Okay.
just how it all kind of starts.
Okay.
I'm confused. Like I get the
We're just talking about how the engine operates. We're going to get to the electrical system next. So does everyone understand the 4 strokes of a 4-stroke engine?
Yes.
Okay? We're going to find out. Zane, right over here. Bone Doctor, slide over 1. Joseph, come back here. Leave everything except a number 2 pencil. Shut everything. Pen is fine. Okay. And then, Solomon, I want to put you back at that table right there. Yep, just stay right there. Okay. Just put everything away.
Do you actually have a pencil I can use in case I mess something up?
There we go.
Thank you.
Okay, my pleasure. You may begin. By the way, in case you're wondering why you're doing that, how many of you really wanted me to grade these?
I definitely just
Sort of me. Sort of now.
All right. Kick it.
Is it okay if I draw them upright, or do you want me to draw them sideways?
You can draw them upright, you can draw them sideways, you can draw them any way you choose, as long as you follow the instructions. For your listening pleasure, we will have holiday music. Take your time with this. This is going to be an indication to me of how you learn. Be thorough.
Would you like us to label everything?
Joseph, if you would for me, down below those 4 boxes, read what it says. What does it say?
It says draw a label, describe each strip.
Ah,
Be thorough. Bonus points for strategic use of color.
I think most of you would do well with just the basics, but
Yeah, I'm just gonna go through this drawing at first.
you have 30 minutes. Is that a Sharpie or is that a dry erase marker?
That is a vis-a-vis expo.
Do not use a dry erase marker.
That would be bad. Highlighter. I'm positive this is not erased.
Really? I don't know. I don't know what would connect that thing. Shh. You done? Yes, sir. I'd rather you didn't move around here. There's a reason that I wanted wandering eyes away from papers. Excuse me. Mm-hmm. Anyone want to answer Zane's question? Solomon?
No. You got it wrong too.
Shh.
I can spell it
Shh,
out.
shh, shh.
EXHAUST.
Thank you. Joseph, this is your first attempt.
That is not my first. Feel a lot better about this one now.
Shh. What is it that you think I'm wanting to see between your first attempt and your second? Thank you. Joseph, you done?
Thank you. Put a little box in the first box explaining the green mark. Sorry about that.
If you need to describe each stroke and need more room, do it on the back. Just create 4 boxes just like the front and use those boxes to describe what's happening in each stroke if you need the extra room. Yeah, 15 minutes. Just, guys, if you need a pen or a pencil or something like that, just let me know. As I said before, I'd rather you not be up and around. Yes, sir.
On some of them, I wrote them in the front, but now that I realize I can write them in the back, I'm going to rewrite all 4 in the back.
You have 14 minutes. Yes, sir.
Can I go to the restroom?
Quickly. Leave your cellular device here, please. Have any of your other teachers mentioned your handwriting? Sorry?
I'll talk to you about that.
Okay. Who are you? Oh. Thank you. Ten minutes. 9 minutes. Done?
Yeah. Don't feel great. Sorry.
'Thank you, Elijah. Hang on here, Anders. Hang on here. Anders, hang on. Thank you. I'm just going to move this cord, Joseph. I just didn't want a chair. I would hate for a metal chair to dig into that cord. Even though you're sitting on plastic, that could be a shocking experience. Five minutes. In 5 minutes, prepare to scribble as you have never scribbled before. Joseph, you can come on back to your seat there. Sure, if you want to. Shh, 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 shh. We're still working. some of you are apparently ready to scribble. Two minutes. 2 minutes. One minute. Who are you?
Solomon.
Are you?
Oh.
Are you now?
Thank you. Here we go. For class on Tuesday. Be prepared to discuss the following. Excuse me?
I'm going to be gone.
We will miss you. But these are going to be the things you're responsible for when you get back. Tuesday. Propeller. Fixed pitch. Constant speed. Twist. You writing this down, Joseph? You recording? Oh,
I'm doing it right now, and I'm just marking the pages.
Propeller, prop, fixed pitch, propeller,
Pro-
fixed pitch, constant speed.
twist. Okay?
That's all chapter 7.
Everything I'm giving you guys here is all right out of this chapter. Carburetor. Carburetor. Explain. Carburetor. Explain. Carburetor ice. Explain. Carburetor heat. Explain. Fuel injector. Fuel injectors. Explain. I will explain to you the difference between superchargers, turbochargers, and turbo normalizers. I will explain that. But I want you to read this so you know what I'm talking about. Solomon?
So what I have is propeller.
We're not even done yet, buddy. So just keep writing. Ignition system. Joseph, in particular, be prepared to explain. Well, here we go. This will be your opportunity to dazzle us. Oil system. Explain. Engine cooling systems. Explain. I'm not going to ask you about the exhaust system because you already know. Starting systems. Explain. I will walk you through electrical systems, but that won't happen until Thursday. I'm skipping the jet engines for now. We talked about the fuel system. Explain. Quickly here, those are the type of fuel options, red, green, and blue, 80 octane, 100 octane, 100 low lead, that I used to have back when I started flying. Now there's only one, 100 low lead. Plus, you have your Jet A. Solomon.
Isn't lead pretty bad? Like, so if it has low lead, doesn't mean it still has lead in it?
Correct. The lead additive is one of the things that the manufacturers want, as it helps lubricate the engine and systems. However, we're moving away from that. Heating systems, we talked about. Electrical system, I will go over, but I want you to read the electrical component of this. Hydraulic systems, I will just touch on. Landing gear, know what types of landing gear there are. Know what it means to pressurize an airplane, the cabin. Understand oxygen systems. Explain. Oxygen systems. Explain. Anti-ice. How do we accumulate ice? Why is it bad, or is it bad? I don't know, it may be nice, it may be lovely. How do we keep ice from forming on the airplane? That'll get us through Thursday of next week. Have a lovely weekend, gentlemen. It is my pleasure.
So I have cover, fixed pitch, constant speed, cover your speed, cover your ice. Give me back my pencil.
Mr. I'm gonna repeat that back.
Hold on. Hold on. Let me turn this off.
Heat explain, fuel injector, fuel injectors explain, ignition system explain, oil system explain, engine cooling systems explain,
My pleasure, Gabe.
electrical systems,
Oh, enjoy your
hydraulics,
weekend.
Thank you very much.